All right, kids, here's a short video that will go over two of the problems that I left for yesterday. This was the students being considering themselves being well off. Let's see, here's your population proportion P. This is your statement here about P hat. There's also your sample size of 200, so all of the information that we need. Checking your conditions, it does say up here in the top that they were the 200 students were randomly selected. That's what it means by SRS, simple random sample. In a confidence interval approach, we base our faith in the sample. And so in our sample, there were 132 students who identified being very well off financially. That meant that 68 of those students did not. And so that means our sample is large enough to use a normal model. And I think I can safely assume that the 200 college students is less than 10% of all college students. Wizards, I'm trying to also illustrate the level of context that I would expect to see in a test of some sort. Also what they would expect to see on the AP exam. So what model are you using? So this is the model I'm using. This is your P hat. This is your P hat. And this is your Q hat, and this is your sample size. So I place my faith and trust. I place my faith and trust in this model. And what I'm going to try to do is I'm going to try to figure out where the middle 95% of that distribution is. So that's what gives me the lower bound of my confidence interval and the upper bound of my confidence interval. So if I was going to construct my 95% confidence interval, ignore that right there. Here's my plus minus step with the square roots, and there's my plus minus step with everything multiplied out. And here's my screenshot from my calculator. So I am 95% confident that between 0.594 and 0.726, I'm 95% confident that the true proportion of college students who think that being financially well off is a important goal is between around 59% and 73%. Is there convincing evidence? Well, in our sample, going back 0.594 and 0.726, 73% is just outside of the upper bound of our confidence interval. So since it's just outside our confidence interval, yes, there is convincing evidence that perhaps the true population proportion does differ from 73%. Interpreting your confidence interval, I am 95% confident that the population, that's the key word I'm going to be looking for, that the population proportion of all first-year students at this university who think being very well off is important is between 0.5943 and 0.7257, and explain what 95% confidence means in context. If you repeatedly took samples of the same size from the same population and you constructed confidence intervals for each of those samples, approximately 95% of those confidence intervals would contain the population proportion. The population proportion of all first-year students at this university who think being very well off is important. And I don't know why I have that statement there. I will mark that one off. I think I had some more copying and pasting than I needed there. Without changing P hat, I described two ways you could make the interval narrower. Well, the first thing you could do is you could use a smaller confidence level, leaving the sample size as 200, or you could use a smaller sample and leave the confidence level at 95%. That's not true. Use a larger sample, that was a teacher technique, and leave the confidence level at 95%. And something we'll work on in the next chapter, what's the alpha level? When we're kind of doing a hypothesis test with a confidence interval. So there's got to be an alpha level, and since this is a two-tailed test and my interval has 95% confidence, that means there is 5% total outside the interval, and I'm going to use all 5% of that since it's a two-tailed test, so my alpha level would be 5%. So that's the confidence interval question. I'll do the hypothesis test question next. Hope this has been helpful.